Is that better? Yeah. Okay. All right. All right. So the topic is, do we have a climate crisis? And I've studied this for quite a few years because I was curious back then as to why there's so much controversy. Why do people think that the Earth is warming so quickly that we have to do something about it? It's really urgent. And so I looked at that from a science point of view. Actually studied for a few months, and I think I understood what the problem was. The agenda is not climate, it is something else, and you'll see that as I get into it. I actually sent out a message to a lot of climate scientists to make some inquiries, and one I got back from a guy that was active on the UN IPCC committee, and he said, if you send me another message, I'm going to sue you. So you can see what they think about confrontation on these issues. So let me just jump through this. Do we have a climate crisis? I'm going to, first of all, talk about what is our biblical mandate regarding climate. Some of the claims being made by those that are active in the, I call them global warming alarmists. Said it's warming so fast we need to do something about this. Some facts about climate change, greenhouse effect, what that means, greenhouse gases that impact this. The UN IPCC is a major intergovernmental panel on climate change. They meet a huge meeting once a year in November, December, and that's where they come up with their decisions and write reports on that. However, there's another group, the non-governmental International Panel on Climate Change, which has a totally different view. They said these are composed of climate scientists, and they also have a conference every year. They had one in February, this past February in Florida, and they write really technical papers. They're peer-reviewed and have a lot of credence to them. So that's just the introduction. What I'm going to spend most of my time on, what are the 16 key issues that we should consider, and then we'll summarize that and then draw conclusions. So getting into that, first of all, what's the biblical mandate? Genesis 1:28, be fruitful and multiply, fill the earth and subdue it, and have dominion over the fish of the sea and over the birds of the heavens and over every living thing that moves on the earth. That is our command from the Lord as how we need to take care of the earth. There's another verse in Genesis 8:22, while the earth remains seed time and harvest, cold and heat, summer and winter, day and night shall not cease. In other words, we can expect climate change, and unfortunately, we have seasons that we can enjoy. It's not always the same. And then from a science perspective, and I think I use this verse in a lot that I do, test everything, hold fast to what is good. In other words, we as scientists should always question science. When some people say the science is settled, or I am science, don't believe them. We got to question them. And whatever I say should be questioned as well. Don't take it as the gospel truth. Question me. If you think I'm wrong, tell me and I'll investigate that. So here's some of the claims. The IPCC said global warming is occurring at a rapid rate, largely due to increased burning of fossil fuels. We must cut back on C2, carbon dioxide emissions into the atmosphere, because that's what's driving the climate. There are representatives of most nations in the world, about 190 nations meet annually to discuss these issues and write reports. They have issued 6 reports so far over the last 30 years. However, many of the claims made are refuted by the NIPCC. And I have followed that for a number of years. All of their papers are published online. Much of this information is accessible to us. It's not hidden. It's right out there. So let's look at some of these specific man-made claims predicted by the UN IPCC. They say it's real, climate is changing, and it's getting hotter, they would say, and it is human caused, they would say. And if we don't do something, we'll be 5 degrees centigrade, which is 9 degrees Fahrenheit, which we're used to, hotter by the end of this century. They say the Arctic ice cap is disappearing, the polar bear population will decline, sea level will rise by 88 centimeters, that's a number of feet, by the end of this century. There will be increased drought, extreme weathers, more tornadoes, more cyclones, what have you, more storms, heat waves, more wildfires. It's a very significant threat to mankind, and it's so bad we need to do something now. So then, what is the reality? So we'll look at that as we go into it. First of all, getting back to the IPCC reports, the first one came out in 1990, and they correctly show that there was a medieval warm period, and there was a little ice age in the 1700s, which we are climbing out of, and so present day we're here. And note that this temperature here is lower than at the medieval period. That's very significant. So then in 2001, the IPCC came out with another report, and that's where we see the hockey stick chart. Some of you may have heard of the hockey stick chart. What they have done is shown the variation in gray in the temperature. Obviously, the temperature on this chart, it's an average temperature, but in the chart to the right here, it's a range of temperatures, and the blue is roughly the center, the average, and the blue are temperature measurements which are done through ice cores or through tree rings or other dating methods, but the ones in red here are the ones that are actually measured by thermometer, and we weren't able to do that till the 1800s or so. And so here looks like a very dramatic change. Note they do not make note of the medieval warm period anymore. The little ice age is buried in the data, and then a huge rise here, or so they say. And this is what it looks like. That's why it's called the hockey stick. So the original version promoted by the IPCC in the 20th century said this is the warmest. You'll see starting back here, and this includes the icy stick and the red here. And look at how warm it is. It's much warmer than it's ever been in the past, including the medieval period. But in reality, the correct version, the 20th century, is no longer the warmest. So in reality, we are not the warmest. There was a medieval warm period back here. So then you can see one of the things they do, there was a big climate gate scandal. I think it was about 2010 or so. And this is some of the data behind that. Going all the way back to 1979, you'll see in the red, this is what was measured and determined here. But then in 2002, all of a sudden the red sort of levels off, and then we get to April 2015, and then all of a sudden they stopped using that. In 2002, they said, well, it's really hotter than that. We look at the temperature measurements, it's really hotter. So it started to diverge from the real measurements, and it keeps on going up, and so it's projected to be much hotter. And this chart here shows you, note the blue, the black here, 1999, this is what the chart looked like, pretty flat. But here, in 2019, all of a sudden, it looks like it's going sharply up. And that is some of the fraud and the involved in these charts, in the data. So actually, for the last 20 years or so, we've had, there's been changes, of course, but it's been, in average, it's been pretty level. Not a big change over the last 20 years. Going back a little further, some of you may remember, if you're old enough, to back in the 1970s, it was cold. We lived in Canada at the time, and the snowbanks were pretty tall. They're not quite as tall anymore. And so there was a warning put out by Governor Brown the Governor Brown Jr. back in the 70s saying, we got a problem here. So even Time magazine recorded that. We got a big freeze coming out, the big freeze. And then all of a sudden, 20, 30 years later, we have global warming concerns. And that's all covered in Time magazine. So that's what the media is reporting. So who were the alarmists? Well, Governor Brown, Dr. John Holdren, who was later Obama's science consultant, he changed his mind. And Governor Brown Jr., who was governor twice, he changed his mind too. Why is that? And this just, so he gave warnings when it was cool, and he thought we're heading into a real cold spell here, and they gave the same warning into the hot spell. So it doesn't matter cold or hot. There was a warning by the same Governor Brown. And you remember this fellow? He said the north polarized cap will disappear in 5 years. That was in 2008. Guess what? It's still there. Here is the science of some of the climate change issues. Our energy truly is from the sun. And scientists can measure that, the strength of that radiation coming down, and then some is absorbed in the surface of the earth, and some is reflected up. Some is reflected up by the clouds, and then on the other side, going back out, the surface radiation, you can see it goes off in various directions as well. Some is absorbed, the back radiation, and that depends largely on the cloud here, this cloud area here, how big that is, how thick that is, and that's where the greenhouse gases come into play. Okay, what are the greenhouse gases? Well, you've heard of carbon dioxide. That is the major one as reported. However, the water vapor is actually a larger greenhouse gas, which is not always included properly in the UN IPCC climate models. But the other one you may have heard of is methane. It is in fact just 10% of what the carbon dioxide is, and then nitrous oxide and a few others. So those are the major components, but what you also don't see in the media is that most of these greenhouse gases are due to natural causes. Only a small fraction, 0.28%, is due to what man does. So whatever we do, even if we stop emitting all carbon dioxide, it wouldn't be a big impact. That's the story there. And this one shows it here, breaking it down again, those various greenhouse gases. The green is the man-made contribution. And for carbon dioxide, it's about 3% of the carbon dioxide in the atmosphere is due to man-made causes. We are burning fossil fuels, and some of that does get into the atmosphere and contribute to some global warming, but is not as significant as people think it is. And this is just another picture of that. So it's a very small part of it. So now I'm going to jump right into the 16 issues. First of all, the statement that climate is always changing. We know, looking back in history from all the way from AD to now, significant things are the medieval period and then the Little Ice Age, and then we are climbing out of that. So the question is, how big are those changes? You'll see on the scale here, not that large. We're just talking about less than 1 degree, one way or the other. So it's not as bad as the media says it is. Now, of course, our weather can change by 10, 20, 30 degrees even in one day. But on average, it's not so large. This, I'm not going to go into all this, obviously. We're not going to cover that. But again, it shows you, even back in Christ's time in the Roman Empire, it was warm. There was a warm period, a small ice age, and then a medieval warming period, and then the Little Ice Age, which is actually pretty big. And then today, small warming, and notice the blue here projecting that we're going to go into a cooling phase. So you can study this graph. I'm going to load all my PowerPoint slides on my website, and you're free to download them and read that chart. It'll take you an hour or so to do that, but that's all right. Okay, carbon dioxide is required for life. In fact, the more carbon dioxide we have in the atmosphere, it increases food production. You hear politicians say, we got to get rid of this carbon dioxide pollutant. Well, it's not a pollutant. It's required for life. And here's one example going back to 1980. I'm just showing you a few of the major crops, grain crops, wheat, rice, and maize. You notice the amount has grown significantly over time, and it has been warming slightly over this period, but of course with fertilizer and other ways we can increase that. If you look at the big picture going back to 1850, the two things here. One is this black line is the yield in corn, which has increased significantly over time. And that's partly due to more land being used and more fertilizer. But on the right there, you'll see who are the significant emitters of the carbon dioxide particularly. Well, first of all, it's Europe, it's the U.S., and it is China. China is now the largest emitter of carbon dioxide emissions. And the other countries, of course, contribute some as well. So we'll come back to that. Here's a picture that I should have mentioned earlier that the amount of carbon dioxide in the atmosphere is now just over 400 parts per million, very, very small. It started out by before the industrial age, maybe 280 or so parts per million. And gradually, this here compares to 3 different concentrations of carbon dioxide in the atmosphere. And you can see with more carbon dioxide in the atmosphere, going from 385 all the way up to 835, it's projected we'd have a much greener growth and taller trees and all that. Number 3, if somebody tells you the science is settled, don't believe them. Science is never settled, as a matter of fact. So we look at some predictions back at for 2015. Again, these names: John Holdren, who is Obama's science advisor, and he was also a scientist back in the 1970s. And so some of the estimates here: the UN estimated the global warming by 2015, all rainforest species would be extinct. Oil will run out by 2015. Well, we're far from that. Arctic sea ice will disappear by 2015. Looking to the future, we could lose as many as 1 billion people. Those are actual projections made by John Holdren and Paul Ehrlich, the other one up here. So, in Holdren, he's one of the scientists who said in 1971, we have a new ice age coming. Let's do something about it. Well, here, if you look at some of the other projections, actual climate change pronouncements by scientists in quotes, in 1970, we'll be in an ice age by 2000. 1976, global cooling will cause a world war by 2000. 1989, global warming and rising sea levels will wipe out entire nations off the map by 2000. And of course, some islands in the Pacific are worried about that, because if the water rose 10 feet or so, that would cause them they'd have to move. It'd be unlivable. Okay, I'm not going to cover all these. Snow will soon be a thing of the past. In 2000, you heard that. Well, we're still getting snow. Global warming will cause fewer hurricanes. Well, that's pretty dramatic. 2012, global warming will cause more hurricanes. Like I said, the science is not settled. There's still questions on that. But they would say the science is settled, you can't question it, believe it, and we got to do something about it. So we have 2,000 years of global temperatures, which look something like this. I've explained this chart before. We did have some cooling in mid-century. If you remember, in the 50s to the 70s, we did have a cooling period. And for those of you old enough to know that, the younger folks won't know that, but it really was deep snow back then up in Canada, and I'm sure here as well. So here we see the temperature. The blue is the temperature here, and it's around zero here, and it went up, and then in this 50, 60, 70 it went down, and then it went back up again after starting in the 80s till the early 2000s. And you see here the other chart I have is what about the solar activity? Look, it's totally coordinated with the temperature. So you think the sun has something to do with the temperature? It has much to do with that. So temperature correlates better with the sun and not with carbon dioxide. And here's another picture which shows that. You'll see here the rise and the down period and the up period. And the carbon dioxide started out at 285 on the left here, and at the end in 2000, just under 2000, is 395 parts per million. So the carbon has gone up, but the temperature hasn't kept up with that. So here again is showing the same period again. What I want to point out here is that we were able to measure temperatures in this time period after the middle 1800s using thermometers and weather stations. Starting in 1979, scientists start to use satellites going around the Earth. They can measure temperature as well in the atmosphere, and the temperature in the atmosphere turns out to be more stable. The temperature on the Earth, obviously, for obvious reasons. Here's, for those that follow this, Michael Mann is the guy that came up with the hockey stick. And he said, this is the chart which describes the past of temperature from 1000 to 2000. And look at this sharp rise. We better do something about this. Well, there's another, a real climate scientist, Tim Ball, who is probably the earliest climate scientist in Canada that started to study this. And he said, well, this is what the past really looks like. There was a medieval warm period, there was a little ice age here, and we're coming out of that. So we shouldn't be surprised to see a little bit of rise, but it's not as big as Michael Mann would claim. And actually there was a lawsuit put out by Tim Ball saying, show me the data, how do you come up with this hockey stick? So he sued Michael Mann for the data. Well, Michael Mann couldn't produce the data, so he won that lawsuit. But you won't read about this in the media. Okay, then we come to the NIPCC, and this is that second group of scientists. These consist of real climate scientists and scholars who study this, peer-reviewed papers, annual conference, and a lot of published reports. These are the main ones here. One concluded that nature, not human activity, rules the climate. Climate change reconsidered. 1 and 2, they look at it again more critically, and they also critique the IPCC's summary for policymakers and explain why there's disagreement. And this is one of the books, the reports they put out, Why Scientists Disagree. Explain why they disagree, and I'll get into that in a bit. The basic findings, you will hear people that represent the IPCC say that we have 97% of scientists agree. We have a consensus. How can you disagree with that? Well, there is no consensus. That's just a self-made consensus. They explain why scientists do disagree because the real scientists, they use scientific method to come up with the truth. And some of the IPCC reports, the scientists produce the raw material for that, but then the politicians, the bureaucrats, they put a twist to that and make it say what they want it to say. And so, but there's none of that in the IPCC. They have false postulates or false assumptions to come up with their conclusions. Unreliable circumstantial evidence. They cherry pick the data to support their story. And then there are policy implications of that, because if you believe what the UN IPCC is telling you, then yes, you probably should do something about it, if it were true. Number 4, what drives global warming? We do have some global warming happening. There are 4 likely causes. Okay, one is, well, if you increase the carbon dioxide in the atmosphere, it should increase the temperature significantly. It turns out that the amount of carbon dioxide in the atmosphere is rather insignificant. And in some cases, the amount of carbon dioxide in the atmosphere actually follows global warming, if you look in the past. So that is not a very significant contributor. Second, well, maybe it's the sunspot. The sunspots in the sun, there's 11-year cycles. Very regular, actually, but the strength of those sunspots can vary, as you'll see. And so the sun itself, can that explain the change in temperature on the Earth? No, it cannot. And I'll explain why. Third, there's the notion of concept of solar irradiance. And some scientists will say this is the major contributor to any global warming that we have. And there's some scientists with ICR, Larry Vardaman, some of you may have heard of him. He's one of the major scientists with ICR, said that this is the major cause of any global warming that we have, and I tend to agree with that. There are other scientists who would say the oscillations in the oceans. I mean, the oceans, the water covers 70% of the Earth, so you'd think that would have some implications on the, on the climate, and it does. And there are cycles in the Earth, which 30-year cycles, which do influence the climate. So first of all, is there any evidence for global warming by carbon dioxide? Well, there's a scientist in I believe she's in Australia, who wrote this report, A Skeptic's Handbook, and she said there's 4 reasons why carbon dioxide is not the major determinant of climate change. First of all, we'd expect to see a greenhouse gas signature, like this on the right here. We don't see that. So that should be a telltale spot there. The ice cores do not show carbon dioxide pushing up temperatures. In fact, in some cases, they see the increased temperatures occur like 800 years before the carbon dioxide increases. Third, temperatures are not rising. Since 1999, temperatures have been pretty flat, as I showed previously. And then fourth, carbon dioxide already doing almost all the warming it can do. In other words, if you increase, even if you double the amount of carbon dioxide in the atmosphere, it's not going to have a big impact on the temperature. This is Mauna Loa. That's a location in Hawaii. It's a mountain, so there are no people living close by, so there's no human interference there. And so they're able to measure the content of the carbon dioxide in the atmosphere. Here, this red line here, and you'll see there's variations up and down according to the season, but it's pretty irregular. You see the increasing here, and all the way up to March 2021. And you also see in the bottom here, there's 3 correspondence here. First of all, with the carbon going up here in 1960 to 75, the temperature, average temperature, is going down, and that's to the cooling period that we had in the 60s and 70s. And then from then up to about 2000, the temperature seems to increase accordingly with the carbon dioxide, But then since 2000 or so, the temperature levels off, but the amount of carbon dioxide in the atmosphere has increased. So there's no good correlation with the amount of carbon dioxide in the atmosphere and the average temperature in the world. And this here shows the atmospheric concentration of carbon dioxide in parts per million. We're here, the pre-industrial level, we had maybe 275 or so parts per million of carbon dioxide in the atmosphere. And even if we doubled it, you'll see the contribution to the temperature increase is shown here. Gets smaller and smaller as you add more and more carbon dioxide. You could even triple it, and you wouldn't have much change in the in the temperature. So third is the total solar. This is the third total solar irradiance, and this shows the. It's got a bunch of charts together. The one at the bottom shows the strength of the sunspots on the sun. And this here shows that graph of temperature. And remember, that's this period of going down, going up, down, and up. So it does vary, and but it's not coordinated with the amount of carbon dioxide in the atmosphere, which is about 380 just before around 2000. Okay, and then here's that chart I showed before, where it seems to me the temperature is correlated with the sun, better than it is with the amount of carbon dioxide in the atmosphere. So total solar radiance, that is the third one that we're considering as a possible cause of any global warming. And here, I showed you these charts before. If you look at the solar irradiance, as measured here, and then the red, compared to the temperature, it seems to be fairly well correlated. Whereas you look at the chart, same temperature, and the amount of carbon dioxide in the atmosphere, it is not correlated. Sometimes it is, sometimes it's not. And so solar irradiance seems to be a major contributor. If you go back to the 1600s, that's when we had a mini ice age, and it's referred to as the Maunder minimum. And then you see the sunspots here every 11 years, another sunspot, and you'll notice that even here, there was a minimum, and so it was cooler in that period. Another minimum here, a maximum, just 30s and 40s, 1930s and 40s, and then the strength of the sunspots has come down, and now is projected, scientists project that it'll be very weak here. And that starting soon, we're going to have another mini ice age, what's referred to as the modern minimum. Now, how low that will be, we don't know yet, of course, but that's the projection from the scientists. And you can see that here, those going back to 1800s, 2000. We are now in sunspot number 24. It's come down, and then number 25 is looking like it's going to be much weaker still. So what is this concept of solar irradiance? Well, there is an interaction in our galaxy and all galaxies. There's a lot of cosmic radiation. So with an inactive sun, you've got high cosmic radiation. If the sun is inactive, the magnetic field for the sun is weaker, and so you have more cosmic rays getting closer to the Earth, more clouds formed, and therefore a cooler Earth. And vice versa, if you have low cosmic rays, you have fewer with an active sun. If the solar cycle is very strong, not much of the cosmic rays is getting down to the Earth's atmosphere. You have fewer clouds, and you have a warmer Earth. And that seems to be one of the major contributors to the what we're seeing. And here you can see the cosmic rays and sunspots. Here's the cosmic ray count. When there's a peak here, there's a valley here in the sunspots. So they're well inversely correlated. And this shows it here. We are now at 2020. And you can see the solar cycle number 25 here is projected to be very low, getting lower and lower, and therefore we have decreasing temperatures. The NASA prediction for solar cycle number 25, it will be the weakest of the past 200 years, with the agency correlating previous solar shutdowns to prolonged periods of global cooling. And you can see that here, going back to the Maunder minimum, and then you have the sun spots getting stronger, weaker here, and then clearly getting weaker here in our time. And so that's projected to lead to lower temperatures. And then you come to the Pacific Ocean, called the decadal oscillations of the oceans. And here, the Pacific decadal oscillation, the index that they have, going back to the 40s, you'll see it's a positive index, positive phase, where we clearly have warming. You'll see in the 1930s, obviously it was a very warm decade, and here in the 1940s to the 70s, we have a cooling period, and so that is also correlated. The Pacific decadal oscillation is coordinated with the temperature, and then here clearly we've had some warming, and then here projected to be back cooling. So both the solar irradiance and the Pacific decadal oscillation they correspond to the temperature that we're experiencing on Earth. And there's the cycles in the oceans is roughly 30 years for the North Pacific, and there's also the El Nino, the southern oscillation every few years. So the ocean has some impact on our temperature, and the sun cycles also have an impact on our temperatures. And the ocean temperature itself is not changing very much. It actually has increased a bit, but you can see on the right here, the scale is very, very low over the last, this is only 10, 15 years here. Okay, number 7, if we fully implemented the Paris Climate Agreement, this is an agreement that was made between the nations at one of these IPC meetings in 2015. It's the work of the UN IPCC. Deals with greenhouse gas emissions, mitigation of those, adaptation, and the finance associated with those. It was adopted December 2015, as some may remember, and it was to start doing some mitigation in 2020. Well, that hasn't been very active yet. We're behind. Signed by 195 nations, but only ratified by 144 of them. If that were to be implemented, what are the implications? The UN itself says it would prevent 0.3 degrees Fahrenheit of global warming by the end of this century, if we implement it. And what would it cost to implement? Estimated to be $65 trillion to $132 trillion. If you spent this much money to make that little bit of change, does that make sense? And some of the final points, I'm going to skip over those because I'm going to run out of time. Some of you know I gave this talk last night over a Zoom call with a Christian group in California, and I realized that it took about an hour and 10 minutes, so I'm going to skip through these very quickly. Here's a very important point. The emission targets for the U.S. and China. The Obama administration agreed to an economy-wide target of reducing greenhouse gas by 82% of which are carbon dioxide emission by, let's say, 27% below what it was in 2005 by 2025. Well, China has not agreed to that. They agreed to achieving a peak of their emissions by 2030. In other words, they can keep on building coal plants until 2030, and therefore they're increasing their emissions while the U.S. is supposed to be decreasing. Okay, so one of the problems we have is the models that the UN IPC uses. This is, there are assumptions built into these models. One is called the representative concentration pathways. It depends on the concentration, your assumptions about the concentration of the carbon dioxide in the atmosphere. If you take a high concentration, you'll get a different result in your model than if you take a low concentration. But so here's the data. The UN clearly makes use of models. And if they look at the results of these models all the way back to 1975 to about 2020, you'll see all these models, because they have different assumptions, they're going to have different projected increase in temperature. The average of those, of the 102 different models, looks like this. However, the fact is the squares are what's measured by the satellites, and the circles are measured by balloon data sets in the atmosphere. They indicate a lower measurement. These are actual measurements, which are much lower than the model says it should be. I mean, if I'm a scientist and I come up with models and it doesn't match the measurements, I would change my model. But they have yet to make these significant changes. And part of the reason is that they assume a positive feedback cycle. In other words, higher temperatures means more evaporation of water vapor in the atmosphere, more heat trapped in the atmosphere, and there are more higher temperatures yet, and all that. But it's the wrong cycle. The NIPCC assumes a negative feedback. The Earth is tuned, to deal with this change in climate. Number 9, weather stations. How were temperatures measured? Well, back in the 1800s and even now, they used thermometers, but the measurement depends on where you place that thermometer. If you're in a rural area where there's not much pavement or concrete, you have a lower temperature. If you're in the suburbs, you have a slightly higher. In the city, you have higher yet. And so you can see if you have a weather station in the rural area, and over time, 1950 to 2010, the city grows around you, your weather station, if you use the same weather station, is going to give you a higher temperature than before. So this needs to be taken into consideration. Here's one case which shows the result of that. The number of stations in the dots here, okay, you can see that goes from 11,500 down to, let's say, 9,000. So what they've done is removed some weather stations, but the result of that is which stations did you remove? Did you remove the cold ones or the hot ones? And so here's the result. The temperature, 1950, 1990, and then all of a sudden you reduce the number of weather stations, from the cold areas, the rural areas, and obviously the temperature increases. So it's a false result. And this is why I say satellite-based temperature is much, much more accurate. And you can see here from 2000 to 2022, 23, actually this is the last one from February of this year, it's pretty flat. And there's not much to be concerned about if you look at this chart. And this is obviously a much, much more accurate chart. The projection, so here polar bears were expected to be extinct. In the 1960s, 70s, there was about 5,000 polar bears. Gore said they're going to disappear. Today we have 25,000 polar bears. So clear his prediction didn't come to be. Number 11, sea levels are not rising as fast as predicted. Some would predict that there's, we've measured here maybe 10 centimeters over 100 years, the level of the ocean. And here are some projections made by scientists, and it all depends on the assumption. It goes as high as like 100 centimeters. You're over 3 or 4 feet there. Well, what's the actual? Here's the sea level. Okay, 9.9 to 7 something, very, very small. But here's on the green line, that's the carbon dioxide concentration. Clearly, as the carbon goes up, it's not impacting the level of the oceans at all. The reality, just to summarize here, even in Europe, as you know, the Netherlands, the land is dropping. That's why we have the dikes and the water behind it. But then the Germany and Norway, they're actually rising. So they're going to get different measurements too. So that has to be taken into consideration. Number 12, Arctic sea ice is not disappearing. Here's an example that the sea ice is supposed to disappear if we're really warming. Well, 2012, here's the size of the ice cap, and here, 2013, a year later, both in August, it's bigger. So there's no, and that, of course, that's just one data point. But if you look over history, like here from 2004 to 2015, these lines here are for different years, but you'll see there's a range. That gray, they all fall within a certain range. And so the media will report, like in June, July, wow, look at the drop in the ice volume. We better do something about this. But they don't show you what's happening later on in the year. And this is just another example of that. So then we come to other weather extremes. We report, well, we got more tornadoes than we've ever had, more cyclones, heat waves, getting hotter, more forest fires, all that. Looking at drought, this goes all the way back to 800 and 2000. You'll see that most of the time, the blue is wet. So most of the time it's wet, and there's a little rise here in Northern California, and some 1400 and back here during the medieval warm period. These are all natural, and there's some man-made contributions to droughts for various reasons here today. And so there's no real change in drought percentage since 1900. Yes, it goes up and down the percentage, but it's nothing significant. And then we come to hurricanes. Aren't we having more hurricanes these years? Well, this one only goes out to 2009, but you'll see back in the 1800s, the number of hurricanes here, a certain category 3 and above, we have a record of them. And the average is actually going down. But that's just one measurement. And here's some actual hurricane measurements. Going back to the 1900s, you'll see Galveston had one of the worst ones with the most fatalities back in 1900. We've had a bad one recently in 2017, about 3,000. But all the others, they're much smaller. So there's no directional change in that. The number of tornadoes, some of you may have experienced tornadoes, and we have seen them too, but the number has not been increasing since 1970. And the same thing here, violent tornadoes above a certain level. Again, the number is not going up. Violent tornadoes, and here cyclones, in India and the Asia countries. So you got the non-severe and the severe in red, and you'll see again the trend is down, not up, as some of the alarmists are saying. And same here, global tropical storm, hurricane frequency going down. Then we come to heat wave. Said, it's getting much hotter today. Well, when was it the hottest? The annual heat wave index, 1930s. That was the some of you may remember that, or your parents certainly remember that. And it definitely was hotter back then. Monthly records by decade of heat waves. And of course, again, in the 1990s, there was also some minimum records, low temperatures in that. So we have a large variation in that time. And here now, there doesn't seem to be as much variation as we are being told. Okay, let me skip some of these. There's different ways of looking at the heat, but you can see always in the 1930, that's when we had a heat wave. Okay. Frequency of wildfires, the number of wildfires over the years, the number, and this is in the U.S., go all the way from 1985 to 2013. Well, we've got quite a large number, but it's not going, it's not going up very quickly. It's pretty flat, the average there. And here's a chart you will not be shown by your media. The fire, the acreage burned in fire back in the 1800s, early 1900s, was very high. And then it came down for certain reasons, and you'll see all the way down to 1960 here, seems to be pretty low. So when they show you a chart in the media, they'll show you a chart which shows just from here, this same kind of charts, from here 1960 to 2006. Oh, look at it's almost doubled, right? But they don't show you back there. So it's very cherry-picked data that they're using. And here's another way to show it, the acreage burned per year. Okay. Snow extent. Remember some of the alarmists said, we're not going to have any snow anymore. Well, and on average, the fall northern hemisphere snow extent has increased over the years on average. Again, not a huge variation, but it has increased. And then people would say, well, this year, this line down here, the outer blue lines, is the period from 1982 to 2012, and the dotted line is the average over those years. And then here, it's a snow mass for the last winter, 21 to 22, and look at it's above the average, way above the average. Why is that? If we're warming, that shouldn't be happening. And same thing with some other measurements like that. They're all within a range, and it's nothing to be concerned about. People say, well, look at the disasters we've experienced here. They're much worse than in previous years. But if you go back to 1990, this number up here is the percentage of the GDP of the country, of the U.S. And you look at the percentage of the GDP that is spent on dealing with natural and climate disasters, it's actually on average gone down a bit. You got some outliers, of course, like that, and this one here in 2017, but the average is still heading down. Okay, this one here, people don't realize that the charter of the UN IPCC is to assess on a comprehensive, objective, open, transparent basis, the scientific, technical, socioeconomic information relevant to understanding the scientific basis of risk of human-induced climate change. So they're not going to look at the sun or the ocean, that because that is all natural, and they don't like to consider that. Summary of some of the reports, 15, and this is a biggie. The UN officials, here's what one said back in 2010. We redistribute de facto the world's wealth by climate policy. One has to free oneself from the illusion that international climate policy is environmental policy. This has almost nothing to do with the environmental policy anymore. And the same person in November that year, one must clearly say clearly that we redistribute de facto the world's wealth by climate policy. Obviously, the owners of coal and oil will not be enthusiastic about this. One has to free oneself from the illusion that international climate policy is environmental policy. Nothing to do with environmental policy anymore. So there you have it. Now, people know that the administration is trying to move us to using renewable energy that doesn't emit any carbon dioxide into the atmosphere. But now we're using very little of that. Here one showing is 12%, which consists of solar, wind, hydroelectric, and some others. But if you look at again, the big picture, I showed you this before, from 1800 up to now, our energy is largely based on coal, oil, and natural gas. They all emit some carbon dioxide into the atmosphere. So they want us to reduce the amount of emission into the atmosphere very quickly. Well, how quickly can you do it? Look at this chart. We're up here. Are we going to get down there to net zero? In 20, 30 years? It ain't going to happen. So something has to give. Another thing that people are not aware of is that conventional cars, they use some metals, and copper is one of the big ones. Electric vehicles, however, they use more copper, and they use some rather obscure metals like cobalt, which is only mined in certain areas in Africa. So the electric cars need cobalt, and they need a lot of graphite. So all of these have to come from somewhere. And of course, the administration is trying to stop mining as well, because that mining itself causes more emissions into the atmosphere. So it's a real quandary that we're facing there. And then this is one I would discuss, but given time, the notion of carbon credits, that could be a big issue. But okay, so now the energy sources that different countries use has a big impact on the cost of electricity. Look at Germany. They're in deep trouble. They stopped using nuclear, and they're moving away from coal and all that. Look at the cost of their energy. It's 4 times what it is or 3 times what it is in the U.S. And all the countries along different mix here. And so that is a real impact that people haven't understood yet, what it's going to cost. And you often hear the politicians say 97% of the climate scientists agree that we've got a problem. 97%. Where'd that come from? Well, I can't get through all of this here, but there are 7 different studies that were done, very, very, shall I say, biased studies. And they're asking two questions here. When compared with the pre-1800 levels, do you think mean temperatures have risen, generally fallen? Well, of course, most people agree it has risen some. I agree it has risen some. Then do you think human activity is a significant contributing factor in changing global temperatures? And that's where the quandary comes in, because what do you mean by significant? And so net, this particular one study, they sent surveys out to 10,000, got about 3,000 back. Of these, 77 were climate scientists, and 75 were climate scientists as well, but they didn't answer the questions properly. So they get this 97% by dividing 75 by 77. Just taking a small fraction of the population here. So in conclusion, here's a summary by Dr. William Happer, who has been a consultant to the administration in global warming. He says the basic science shows increasing levels of carbon dioxide, nitrous oxide, and methane will not cause a climate emergency. This is another extraordinary popular delusion, madness of crowds, in the sad history of human lust for money and power. Folly and cowardice. It's all about the money. More carbon dioxide will benefit life on Earth because of its value to agriculture, forestry, and life in general. More nitric oxide and methane will have negligible effect on the Earth's climate. Rational people need to push back against climate fanaticism, which is not based on science at all. Appeasement will not work. So why do the secular scientists think that the Earth's climate is unstable and a problem? Well, big thing is their models. Their models are incorrect. Second, the fraud involved in the research. You'll see they've changed some of the data to support their conclusions, and that's not what you do as a scientist. Cherry-pick data, manipulated data. And what does the news media tell you? There has been no global warming in 19 years. Let's see. All these things here. So the news media is not telling you these things. Okay, what should we do as a church? Well, we should be committed to viewing the world from God's perspective, going back to Genesis 8:22. We understand, rely on Scripture as a foundation for life, use the Bible to understand the world and evaluate all problems, and help inform other believers, promote truth and oppose false beliefs, and gentleness and respect. So models have failed. Man-made causes are insufficient to cause this warming that we see. Natural causes can explain it. And the Paris Climate Agreement is not a solution for a non-existent problem. There are more than 60 books that I've identified that refute global warming and refute global warming alarmism. And some of these are by authors who used to believe in in warming alarmism, and now have come around and said, nope, that's not possible. So with that, I'm going to draw it to a conclusion. Sorry for the speed going through some of these charts, but they will be on my website, and you can take your time reading them if you have an interest. So, yeah. Father, we come to you just to thank you for this time. Thank you for your word. Thank you for the truth which we see that you have given us. You have given us a mandate to take care of the earth, and Lord, just help us to do what we can to do that, to fulfill your command. But we thank you for the information you have made available. I pray that you would just bless